So similar figures work from the 23rd. In addition to our midpoint work, we had similar figures work. This document, actually, this beginning part on similar figures is related to middle school content, talking about how corresponding sides ratios are like the ratios when we set up a fraction. You see short side length over here compared to this one. Sitting in the same place, they correspond. We've talked about this. BC gets compared to EF. AC gets compared to DF. So matching up what sides correspond and setting up ratios. We talked about this, I believe, on Friday when I saw you. Last week we spent some time talking about corresponding sides and ratios. So telling whether the figures are similar, you've got to match up sides that correspond and decide if those fractions are equivalent to each other. And so I would be looking at, from the small figure to the big figure, comparing 4 to the side that's 16. And then I'd be looking, and I'm just going back to the way it was presented here. So you can make changes. The question is, if these are similar, these fractions would all be equal. Does 4 compare to 16 the same way that 3 compares to 12? 3 and 12. And does that compare the same way to the way that 5 compares to 20? And if I reduce all of these fractions, they're all equal to a quarter. I'm not addressing your question right now. They're all equal to a quarter. And since these are all 0.25, then we've got permission to say, yes, these figures are similar. And we could even go so far as to say that the size changes a quarter. And we did that in transformations, talking about size changes. The small one is a quarter the size of the big one. And then in 2, we've got a rectangle, so we really only need to compare 2 measures. Is 27 over 9, is that equivalent to 21 compared to 7? And both of those wind up being 3. So our answer would be yes. And actually, where it says explain your reasoning, I feel as if I'm actually showing it. I'm showing how I'm thinking about it. You could write it out in words, but I'm showing how I'm thinking about it. Now, the thing that I think is interesting about 3 is that the orientation of this smaller this smaller rectangle throws me off a hair. I've got to actually think about moving it long ways, and there's 4 and there's 9. That might have changed how you look. That might change how you set up your proportions. And so really it should be comparing 4 to 24. Is that equal to 9 over 45? Now 9 over 45 is a fifth. And 4 over 24 is actually a sixth. Those are not going to be equal if you go at decimals for those. So these guys are not similar. Okay, so just to get you moving on using similar polygons, and I'm not going to work through everything, but I did set up one of these problems. I said compare x to 24 and 10 to 15. And notice I'm not doing anything with this number down here. I'm comparing x to 24 and 10 to 15. And then I showed you about cross multiplying. X times 15 is where I got 15x. 24 times 10 is where my 240 came from. And then you just told me that to finish solving this, I would divide by 15 on both sides, and that's 16. Done deal. Now, looking at number 2, and again, I'm going to get you set up on a few. I'm not going to do them all. Looking at number 2, I'm just kind of trying to see if the orientation is the same. I'm thinking x and 25 should be compared, and I've got 12 to 15 to compare. So I've got to have equal ratios to compare. X over 25 should be equal to 12 over 15. And then, again, I'm going to cross multiply. 15 times x is going to give me 15x. And 25 times 12 is going to be 300. And then to finish this, you would divide both sides by 15. What's that? Would you guys say 20? Okay. So moving on, I'll set up a couple more. Let me set up 4, 6, and 8, and then I'm going to leave you to do the rest. Number 4, for problem 4, the orientation of these figures is a little bit different. I have to kind of imagine this one being flipped around. I'm thinking 6 and 12 should go together, and 5 and x should go together. So I would set this one up. 5 over x is the same as 6 over 12, and solve that. I can look at it and see what that answer is, but get it set up on your page. Now number 6, And again, just setting them up. Roll with me here. Number 6, I need to figure out what the question mark is. So the X is where I'm dropping that. I'm dropping the X in. I think that this side is going to compare. This is the shortest on this figure. And I think it's going to compare to the 35 on this figure because that's the shortest over here. And then this one that almost looks like a hypotenuse, I think 54 probably is going to be compared to 63. So I have to have an idea about matching up corresponding parts. X over 35 is going to be equivalent to 54 over 63. So definitely have to go into your calculator for that. Now from this, for number 8, we've got this presented a little bit different way. Notice how they say A to B. A to B is 2 to 3. I got to put values for A in the top because that's going to be represented by the 2. I got to put values for B in the bottom. That's going to be represented by the 3. So 2 to 3 is equivalent to X to 12. And I just put that AB there to get it set up right. And then I'm going to cross multiply and figure out what X is for that one. A to B again, 1 to 7. A to B, 1 to 7. A to B, 7 to X. Number 12, A to B again, 1 to 2. Our ratio, our colon here, just represents a fraction, A to B. So there's some direction on how to set that one up.